Hello, this is a short demonstration on how to get up and running with the Z2 environment. This is a recording of a tutorial that can be found on the website at www.z2-environment.eu. The Z2 environment addresses problems typically found in Java solution development. First of all, building your projects is complex and tends to become unreliable over time. Deployment of components is time-consuming and tends to make developers defer integration. This is because keeping the local development environment up to date is so complicated and eventually gets ignored, so that after a while each developer works with a different combination of component versions. In support situations, finding the right sources can become virtually impossible. The key idea of Z2 is this. Apart from a small core, Z2 synchronizes with repositories that can be remote or local, such as a Subversion repository or a development workspace. Typically, a complete system is identified by a repository URL. Z2 downloads and compiles resources on demand so that no binary deployment is ever needed. In other words, the source is the system. Now let's turn to the demo. What we're going to do is that we will set up a local instance of a system that is designed in the trunk branch of the Z2 base code line that can be found on the website as well. We will set up a development workspace and see how modifying and testing works with Z2. The image we're working on is a clean Amazon image that has been altered by installing a Java runtime environment, the Eclipse development environment, as well as the Subclipse Subversion plugin that can be found at tigris.org. Now, let's start the development environment and configure the code line as a Subversion repository destination or repository location. We go to the Subversion perspective that is provided by the plugin, the Subclipse plugin, and enter the repository location URL. That is http www.z2environment.net/svn/z2 base trunk. Now, installing an instance means to put a precompiled Z2 core version distribution onto your machine. By convention, we recommend to actually check this precompiled Z2 installation into the same code line that the rest of the system is defined in. The Z2 core is like the minimal part of the system that enables it to bootstrap from the Subversion repository. And as such, it will be rarely changed and is something that can be kept relatively stable on the system. It's more like a static distribution part. So by convention, we check this into the L0 level 0 folder in the branch trunk, in the branch that holds the system definition. So let's check it out. We check it out into the workspace so that the development workspace is in many ways directly identified with the right core distribution that defines the rest of the system, so that there's no confusion about what belongs to what system definition. Okay, here we go. Let's go back to the Java perspective. So the Java perspective contains a Z2 base folder now. The name Z2 base was actually part of the project description that was also checked in. Now, starting a local instance actually means to start a shell script or batch file, and for convenience we will create an external tool with Eclipse that does exactly that, starting the batch file. So we go to new external tool configuration, give it a meaningful name, pick the batch file from the project. It's GUI.bat. And as we're working on the Windows, we have to define the working folder as well. Okay, so that's it. Apply the configuration, start it up. On the first start, the system will actually have to bootstrap from Subversion and download and compile and prepare all the resources required to achieve its target states. Now, at first start, this takes a while, actually depending on your network bandwidth. Subsequent startups will be substantially faster. However, that gives us a little time to have a look at the console here. This GUI console that comes with the L0 with the Z2 core distribution is useful for development. It provides a convenient overview over all the log file output of our worker processes. It gives us a way to trigger a synchronization of this home. You can clear the console here, and you get an easy and simple overview over the worker processes and their current state, and you can stop them from here if you want, restart or see if they're alive. Now you can tell from this line here that the worker process environment / web worker has just been started and is already up. And you actually can see some of the sample application output here in the console. So now let's have a look at the sample applications that come with the Z2 base system. Let's open a browser and go to HTTP localhost port 8080 /wicked WICKIL, which is Wicked Image Library. This is a very basic web interface that allows you to upload images and change them. It's only there for the purpose of the demo and to have something running. What we will do is that we will check out this application, have a look at the source code and modify it in order to get a feeling how development and modification actually works in Z2. In order to have a look at the application, let's go back to our Subversion perspective and have a look at the L1 folder. So close the L0 folder and go to the L1 folder in the Subversion branch we defined before. The L1 branch already contains resources that Z2 introspects automatically and downloads as required and prepares and compiles and so on. It contains lots of Z2 specific parts. Actually, most of the stuff that makes the runtime is in L1, and in this case it also contains the sample applications. Z2 can actually connect to several repositories, and you can easily split parts of a solution if you want into different repositories. Now, these sample applications are actually provided by the 3 projects here, but of course these projects require lots of different stuff like the web app APIs. Now, the project this application is actually defined in, the application we just looked at, is the sampled.wicked.imagelib project. So let's check this project out and have a look. That should be fast. Now, going back to the Java perspective, you can tell that this project can of course not compile. That is since Eclipse has no idea how to satisfy the dependencies of this project. It's as simple as not finding the web container APIs, which is something that Eclipse theoretically could do on its own, but there's other APIs, in particular also Z2 APIs, that Eclipse wouldn't have an idea about. Now, we could, of course, theoretically check out everything that's in the system and that's required by this project. In larger solutions, however, that's an unrealistic requirement and puts a lot of burden on the single developer to keep its workspace A, tidy, and B, up to date. So in order to And obviously the Z2 runtime has an idea about where the the libraries are that are required by the application, since the Z2 runtime is capable of executing the application. In order to close this gap, so in order to make your local workspace projects compile against dependencies that are actually known by the runtime, Z2 provides a little Eclipse plugin that can fill an Eclipse class bus container that actually moves Z2 provided binaries that have been built and assembled on the fly by the Z2 environment, puts these binaries in a location so that they can be found by your Eclipse workspace. In order to do that, we have to install, or we will actually install, this little plugin, which is actually hosted by the very same environment you're running here. So in order to install this plugin, now go to Help, Install New Software, and type HTTP localhost 8080 Eclipsoid. That is the name of the plugin. Update site XML. So the full URL is localhost 8080/eclipsoid/update/site XML. You will also find this URL in the tutorial on the website. Now check the plugin, press next. Yes, we accept the license agreement. Install the plugin, which takes amazingly long, considering that it's a very, very small plugin. Okay. Now, okay, and restart Eclipse.